Hi everyone, Mrs. Besega here, and today we're learning how to draw free body diagrams, or FBD. A free body diagram is a representation of all the forces acting on a single object. I call it a systematic way to draw because we're all going to draw these diagrams in the same way. That way we can all interpret each other's work clearly. And the first step of drawing a free body diagram is to draw the object we're working on. And I'm sorry, artists, but we're going to simplify this in a physicist-friendly way. So whether you're drawing a cow or a dog or a person or you or a planet, it's all going to be a dot. Step one in drawing a free body diagram, then, is to draw your object as a single point. That's actually trickier than you think. We'll talk about it soon. Next, we're going to draw some arrows. Every force that acts on an object is going to be represented by an arrow. So let's give you an example so you have one to work with. Let's say I have a baseball falling to earth. I don't know why I drew the tree. It's not falling from the tree. That doesn't make sense. There's two forces acting on the baseball: the gravitational force of the earth and the air resistance force. The longer I draw my arrow, the stronger my force is. And since gravity is stronger than air resistance, I'm going to draw an arrow that points down away from the dot and an arrow that draws up away from the dot. If you know the number associated with either force, feel free to write that number into your diagram. But that's basically it. Dots and arrows, where long arrows represent large forces and small arrows represent short forces. So let's do some examples. In this example, let's say I have a box sliding across the table. Okay? First, we identify the forces acting on the object. Our object is drawn as a dot, and because I'm anywhere near the surface of the earth, gravitational field or gravitational force points down. I know the box isn't sinking through the table, so that must be supported by the normal force. I'm going to indicate that those forces are equal with little geometry symbols. Since my box is sliding to the right, friction would be acting to the left. I assume the friction arrow is going to be smaller than either the normal force or the gravitational force. Let's try another example with different forces this time. Let's say I have a fancy sign and it's suspended in the air. It has two tension forces acting on it from the two strings, and those tension forces are at angles to our object. So first off, is the sign near a planet? Yeah, it's got a gravitational force. Then I'm going to draw two tension forces in the same direction of my string. I'm labeling them T1 and T2 to be able to tell them apart. And if I know the angles, let's say this angle is, that looks closer to a 30 degree. Let's say this is a 30 degree angle and a 60 degree angle. If I know the angles, write them in. Let's add that even as like a third thing to consider. If you know the angles or the number of newtons associated with that force, you might as well include that on the diagram too. So I'm going to write this as label non-perpendicular angles. I don't need to label the angle for this drag gravity example because it's up and down. And for a third and final example, let's say I have a person leaning against a wall. Leaning against a wall yields four forces acting on our person. So there's my person, very slick there. Hey. I'm going to draw my person as dot. They're near the earth, so a gravitational force. They're not falling through the floor, so you bet they're being supported by a normal force. Those forces are equal and opposite, or else that person sinks into the floor, and that's not true. We know the person's applying a force to the wall in order to lean on it. but they're not falling through the wall either. That must mean there's a second normal force, the force of the wall repelling our guy to the left. So here's our scenario. We want to draw free body diagrams by drawing your object as a dot and your forces as arrows. Your arrows should be labeled with the type of force, should be drawn proportionally to the strength of the force. They should point away from the dot in the direction of push and pull, and you should label any numbers, such as angles or forces, in your diagram. So let's go practice this new skill. We're going to practice with a few full class examples drawing free body diagrams together. Good luck!